Hello everyone, my name is Shalini, student of SVCE. In this video, I'll be talking about Cpsr. Here we have the contents, introduction, components of Cpsr, importance of Cpsr in microcontrollers, Cpsr registers and their functions, accessing and manipulating Cpsr, Cpsr flags and their significance, Cpsr and interrupt handling, Cpsr and conditional execution, Cpsr and power management, optimizing Cpsr in microcontroller applications, usage, example, conclusion. Starting with the introduction, CPSR or Current Program Status Register is a specialized type of memory used in many modern microcontrollers. It offers fast access times and low power consumption, making it ideal for embedded systems with limited resources. In addition, the CPSR is a critical register in microcontrollers that stores the current state of the processor, including flags, interrupt status, and mode information. In ARM Cortex-M based microcontrollers, the CPSR is a 32-bit register that provides real-time visibility into the processor's operating mode, condition flags, and interrupt control. Accessing CPSR, developers can directly read and write the CPSR register to control program flow, enable interrupts, and optimize power usage in their microcontroller applications. Components of CPSR, condition code flags. These flags indicate the result of arithmetic and logical operations. N negative is set to 1 if the result of the operation is negative. Z0 is set to 1 if the result of the operation is 0. C carry is set to 1 if the operation resulted in a carry out. V overflow is set to 1 if the operation is resulted in an overflow. Control bits, I interrupt disables IRQ interrupts when set. F fast interrupt disables FIQ interrupts when set. T thumb state indicates whether the processor is in thumb state 1 or ARM state 0. Processor mode bits. These bits indicate the current mode of the processor, example user mode, FIQ mode, IRQ mode, supervisor mode, etc. Importance of CPSR in microcontrollers. The current program status register CPSR plays a crucial role in the efficient operation of microcontrollers. It provides essential information about the current state of the processor, enabling fine-tuned control and optimization of system performance. By managing CPSR, developers can precisely control interrupt handling, task scheduling, and conditional execution, leading to improved responsiveness, power efficiency, and overall system reliability in microcontroller-based applications. CPSR registers and their functions. CPSR registers. The CPSR is a special purpose register in microcontrollers that holds key status information about the current execution state. Flags and bits. The CPSR condition flags such as the carry 0, negative, and overflow flags, which provide essential information for conditional execution and interrupt handling. Processor modes. The CPSR also specifies the current processor mode, such as user, supervisor, or interrupt modes, which determine the available privileges and memory access. Accessing and manipulating CPSR. Reading CPSR. The CPSR register can be read using special instructions like MRS, move to register from special register, to retrieve its current state. Modifying CPSR. To update the CPSR, you can use the MSR, move to special register from register instruction. This allows you to set specific bits within the CPSR. Bit level access. Advanced techniques like bit masking and bit shifting can be used to access and manipulate individual flags within the CPSR register. CPSR flags and their significance. Condition flags. CPSR contains condition flags like negative, 0, carry, and overflow that indicate the result of arithmetic and logical operations. Mode flags. Mode flags in CPSR determine the current processor mode, enabling privilege levels and access to specific system resources. State flags. CPSR also includes flags for the current processor state, such as the thumb state flag, which switches the instruction set. Interrupt flags. Interrupt enable or disable flags in CPSR control the microcontroller's response to external interrupts, ensuring proper interrupt handling. CPSR and interrupt handling. Interrupt priorities. Managing interrupt priorities within CPSR. Interrupt masking. Enabling and disabling interrupts using CPSR. Interrupt latency. Optimizing interrupt responsive time with CPSR. The CPSR plays a crucial role in handling interrupts on microcontrollers. It allows developers to set interrupt priorities, enabling or disabling specific interrupts as needed. By properly managing the CPSR during interrupt service routines, programmers can minimize interrupt latency and ensure real-time responsiveness in their applications. CPSR and conditional execution. Conditional execution. CPSR plays a crucial role in enabling conditional execution in microcontrollers. The status flags within CPSR allow the processor to evaluate conditions and make decisions based on the outcome. Branching based on flags. Microcontroller instructions can branch to different code paths depending on the state of CPSR flags, such as zero, carry, or overflow. This allows for efficient conditional logic and flow control in the program. CPSR and power management. The CPSR plays a crucial role in microcontroller power management. It allows developers to configure low power modes, control clock gating, and optimize energy consumption for various operational states. By manipulating CPSR flags, designers can seamlessly transition the microcontroller between active sleep and deep sleep modes, striking a balance between performance and power efficiency. Optimizing CPSR in microcontroller applications. Efficient CPSR manipulation. Leverage direct CPSR register access and bit level manipulation techniques to optimize performance and minimize execution time. Targeted CPSR modifications. Carefully analyze your code and only update the CPSR flags that are necessary, avoiding unnecessary register writes. Interrupt aware CPSR handling. Properly save and restore CPSR state during interrupt service routines to ensure seamless context switching. Power optimized CPSR configuration. Leverage CPSR flags to enable power saving modes and reduce energy consumption in low activity scenarios. Usage. Condition monitoring. By checking the condition code flags, the CPSR allows the processor to make decisions based on the results of previous operations. Example, branching if a result is 0 or negative. Interrupt management. The CPSR can enable or disable interrupts, allowing critical code sections to execute without interruption. State switching. The CPSR facilitates switching between different execution states, such as ARM and thumb states in ARM processors. Example, consider an ARM processor executing an instruction that adds two numbers. Here we have the code, add R0, R1, R2. R0 equals to R1 plus R2. R1 and R2 are the source registers and R0 is the destination register, and the result will be stored in R0. After this instruction, the CPSR will be updated based on the result. If the result R0 is 0, the Z flag will be set. If there was a carry out, the C flag will be set. If the result is negative, then N flag will be set. If there was an overflow, the V flag will be set. Conclusion. The CPSR is a critical register in microcontrollers, especially in ARM architectures, as it provides essential status and control information that governs the operation of the processor. It is crucial for handling conditional operations, managing interrupts, and controlling the execution state of the processor. Thank you.